Hey everyone, Mr. Evans here with your pre-recorded live lesson on Unit 3, Lesson 5, the 10% rule. This is going to be kind of a short one because we have already gone over a lot of the stuff in this lesson, so this will be largely a review today in this one. So in a nutshell, the 10% rule states that 10%, generally speaking, of the energy from one trophic level is passed to the next trophic level up when it is consumed. So for example, a primary consumer, when it eats a producer, will take on 20% of the energy from that food source. That's a very loose term. It's not exactly 10%. It's more of like a generalization thing. Obviously, it will depend on what plant is being eaten and the animal itself, how efficient it is in digesting and capturing energy. But it's just kind of a term to let you know that eating is an inefficient process. When you eat something, you don't automatically absorb 100% of its energy. In fact, you absorb very little of it. Most of what you eat passes through your body as waste, or it is actually released as heat to the environment. So this image right here, which is from your lesson slide, represents a food chain, a simple food chain in a marine environment. So down here you have the producers, and it's kind of arbitrarily using the number 2500 energy units. We'll just call them energy units. So these are the producers down here in the sea, and these could be things like kelp, seaweed, algae, plankton, anything that can photosynthesize and create its own food. These are all the producers that don't have to eat anything. They make their own food from sunlight. Well, when a primary consumer eats them, this graph is saying that it will only get 20% of the energy from those producers. I know the lesson says 10% rule, and then it immediately goes and uses 20% as an example. I don't know, but I'm just explaining to you that the number itself isn't important. It's more the concept. So it basically takes 2,500 energy units of producer to support 500 energy units of primary consumer. So these would be fish that eat the plankton or herbivores that live in the sea, things like that. So up here is the next level. This would be the secondary consumer. And in this example, it uses a herring, which is a fish. So the herring will eat the stuff that eats the producers. So we're moving up the food chain here. And then the next step up is a mackerel, which is a different type of fish that eats the herring. And then the last step up is the tuna, which is the last step in this particular food chain. This would be a tertiary consumer that eats the mackerel. So notice how this shrinks as you move up the chain. So what this graph is saying here is that it takes 2,500 units of producer to create 0.5 units of tuna. So it takes a lot of producer biomass, a lot of volume to support a little bit of tuna. And as you move up the food chain, up the food web, the process gets more and more inefficient. So it takes a lot of biomass, and we saw that term in the last lesson. Biomass is just organic stuff to support the tertiary consumers, because it all starts down here at the bottom with the producers. So in terms of efficiency, the primary consumers, the herbivores, are the most efficient in terms of supporting their own populations using producers. I'm not sure if that kind of makes sense, but you have to visualize it in your head. For an example, in like human society, one of the big arguments for being vegetarian is simply the amount of energy and plants and effort that it takes to produce meat. And that is true on like a very large scale. Think about all of the energy that goes into producing a cow and growing it up for, 5, 6 years until it's old enough to be slaughtered and turned into hamburger. You got to feed that cow for 5 years. Think of all the grain and corn and oats and stuff that cow has to eat to
get to the point where it's mature enough to be eaten itself. That's a very energy intense procedure. And we're only talking about a primary consumer right there. The next chain up, the human, I mean, if you're a meat-eating human, think of all the energy it takes to produce the food that you eat. And that is just straight up talking about the energy in the plant. That's not even taken into account the gas that goes in the tractor or the rancher who's doing their work. That's on top of all that. So that is the 10% rule. As you move up the food chain, the efficiency of using the energy gets lower and lower and lower. And also in the lesson here is another graph. This is the same type of graph. It's just kind of turned the other direction. But this is kind of representing where that energy goes. And when you're talking about energy transfer, whether it is a life form or a car engine. A car engine uses energy transfer too. You take an energy from the gasoline and you are igniting it, you're creating a combustion reaction, and that energy is converted into kinetic energy that it makes a piston move, that drives a crank, that turns your wheels, that makes your car go forward. But think of all the energy that is lost to heat in that process. Your car engine heats up. Heat is lost out of the muffler exhaust. So the majority of the energy in that gasoline is not being used to drive the car. Only a small amount of it is. Most of it is being lost to heat that's just escaping out into the atmosphere. It's the same thing with life. A plant actually emits heat. It absorbs energy from the sun, but a lot of that is reflected back, or it is just released as heat as the chemistry of photosynthesis and the other life functions of the plant proceed. And it's just lost in the atmosphere. That's an inefficient energy transfer. So as you move up the food chain, all of this energy is lost to heat to the atmosphere. So it's an inefficient process. So that is the 10% rule in a nutshell. It's called the 10% rule, but the number itself might be different from time to time, so don't get too caught up in that. Just understand the concept that as you move up the food chain, energy is lost. It takes more and more of the bottom part of the pyramid to support the top part of the pyramid.
All right, that's going to do it for today, and your multiple choice question is coming up right now. Have a good day.